Welcome to the topic of measurement. At the end of this lesson, you will know how to recall and apply the formulae for calculating the area of a rectangle, triangle, parallelogram, and trapezium. Recall and apply the formulae for calculating the circumference and the area of a circle. Recall and apply the formulae for calculating the length of an arc or area of a sector of a circle given the angle subtended at the center of the circle by the arc. Estimate the area of an irregularly shaped figure, especially when the figure is drawn on a grid. Recall and apply the formulae for calculating the volume and surface area of a cuboid, cylinder, and any right prism. Use given formulae to find the volumes of spheres, pyramids, etc. Recall and use the SI measures of area, volume, mass, temperature, and time, including the 24-hour clock, and solve problems involving distance, time, and speed.
Lesson 1. The formula for the area of a rectangle is a well-known formula. It reads, area of rectangle equals length times breadth. The problem is to find the area of triangle ABC given the length of its base AB and the corresponding height CD. If we construct the rectangle AEFB as shown to enclose triangle ABC, it is not difficult to see that the area of triangle AEC equals the area of triangle ADC, and the area of triangle BFC equals the area of triangle BDC. Therefore, area of triangle ABC equals half area of rectangle AEFB, which equals half AB times CD. Therefore, area of triangle equals half base times height. Note that this formula holds true, no matter what shape the triangle takes. For example, the triangles shown all have the same area of half times B times H. Let us look at an example. Find the area of this shaded figure. This area is clearly obtained by subtracting the area of the triangle from the area of the rectangle. That is, shaded area equals 6 times 8.5 minus half times 6 times 4.5 centimeters squared, which is equal to 51 minus 13.5 centimeters squared, which gives 37.5 centimeters squared. The volume of a pyramid is similar to the volume of a cone and is equal to 1/3 times area of base times height, which is equal to 1/3 AH. Remember that the base does not need to be triangular for this formula to hold. Let us try an example. Water is poured into an inverted cone of base radius 10 centimeters and height 15 centimeters. How long would it take to fill the cone if the water is poured at a rate of 1.5 liters per minute? The volume of the cone is 1/3 pi r squared h, which is equal to 1/3 times 3.1416 times 100 times 15 centimeters cubed. This gives 1,570.8 centimeters cubed. Therefore, the time needed to fill the tank is 1,570.8 divided by 1,500 minutes, as 1.5 liters equal 1,500 centimeters cubed. That is 1.05 minutes to 3 significant figures. Let us look at another example. An open pyramid ABCD with a triangular base ABC right-angled at B is of height 12 centimeters. The pyramid is filled with water. A lead sphere of radius 2 centimeters is then gently placed in the water and sinks to the bottom as shown, causing some water to spill out of the pyramid. What is the volume of water still remaining in the pyramid? The volume of water remaining is equal to the volume of the pyramid minus the volume of the sphere, which is equal to 1/3 the area of base times height minus 4 pi r cubed divided by 3. This gives 1/3 times, a half times, 5 times 8 times 12 minus 4 times 3.1416 times 8 all divided by 3 centimeters cubed. This is equal to 80 minus 3.1416 times 32 divided by 3 centimeters cubed, which is equal to 46.5 centimeters cubed. The net of a solid is a plane figure which can be folded in such a way that it forms the surface area of the solid. For example, a cuboid 15 centimeters by 6 centimeters by 3 centimeters can be assembled by using the net shown below and folding along the dotted lines. Why would this figure serve as a net for constructing the surface of a closed cylinder? The circles, of course, would be the two circular ends, but what about the rectangle? If we fold the rectangle as shown, it is not difficult to see that it would form the curved surface of the cylinder, as long as the length of AB in Figure 1 equals the circumference of either circle and BC equals the height of the cylinder. From the net, we can see that the surface area of a closed cylinder is equal to 2 pi r squared plus area of rectangle, which is equal to 2 pi r squared plus AB times BC, which is equal to 2 pi r squared plus 2 pi rh. Suppose we take the curved surface of a cone and cut it along VA as shown in the diagram. What would be the shape of this curved surface when it is opened out? If you saw that the shape would be a sector of a circle of radius L, which is the slant height of the cone, congratulations. The length of the arc AB would be the circumference of the circular base of the cone, which is 2 pi r. Note that the angle theta degrees of the sector could then be found using theta divided by 360 equals 2 pi r divided by 2 pi L equals r divided by L. The net of the closed cone would therefore be as shown, where AB equals 2 pi r and its total surface area would be theta divided by 360 times pi L squared plus pi r squared equals r divided by L times pi L squared plus pi r squared equals pi rl plus pi r squared. Note especially that the curved surface area equals pi rl. First of all, we can note that SI stands for System International. That is, an international system of weights and measures established in 1960 at the 11th General Conference of Weights and Measures. The SI unit of mass is the kilogram, approximately 2.205 pounds, where 1 kilogram is equal to 1,000 grams. The SI unit of length is the meter, approximately 39.4 inches, and the corresponding units for area and volume are square meters, m squared, and cubic meters, m cubed. Note also, however, the hectare 10,000 square meters and the liter 1,000 cubic centimeters. As shown in the diagram, as 10 millimeters equal 1 centimeter, a square of side 1 centimeter can be split up into 10 times 10, which is equal to 10 squared square millimeters or millimeter squared. This result applies generally. For example, as 100 centimeters equal 1 meter, 100 squared centimeters squared equals 1 square meter, and as 1,000 meters equal 1 kilometer, 1,000 squared square meters equals 1 square kilometer. Again, we see that 1 centimeter equals 10 millimeters, 10 cubed cubic millimeters or millimeter cubed equals 1 cubic centimeter. For example, as 100 centimeters equal 1 meter, 100 cubed cubic centimeters equals 1 cubic meter, and as 1,000 meters equal 1 kilometer, 1,000 cubed cubic meters equal 1 cubic kilometer. Look at this example. In a previous question, we found that the area of the Earth's surface covered by water is approximately 0.71 times 4 times 3.1416 times 6,378 squared kilometers squared. How many hectares would this be equivalent to? 1 hectare is equal to 10,000 meters squared, so we need to change kilometers squared to meters squared. That is, multiply by 1,000 squared. The area covered by water would then be 0.71 times 4 times 3.1416 times 6,378 squared times 1,000 squared square meters. This is equal to 0.71 times 4 times 3.1416 times 6,378 squared times 1,000 squared, all divided by 10,000 hectares. This is equal to 3.629 times 10 to the 10th power hectares, to 4 significant figures. You can now attempt the following multiple choice questions. The answers will be given at the beginning of the next lesson.
Is the area of the shaded region in this figure, where ABCD is a rectangle, equal to A, B, C, or D? What is the area of triangle PQR in centimeters squared? Is it A, B, C, or D? In the diagram, ABCD is a rectangle. M is the midpoint of AB, and BN is equal to 1/3 BC. The area of the shaded triangle MBN is therefore what fraction of the area of the rectangle? A, B, C, or D? The grid consists of centimeter squares. What is the area of the quadrilateral ABCD in centimeters squared? A, B, C, or D?
Before we begin Lesson 2, these are the responses to the questions from Lesson 1. The correct response to question 1 is C, as the shaded area equals the area of the outer rectangle minus the area of the inner rectangle, which is equal to 15 times 12 minus 11 times 8 centimeters squared, which gives 92 centimeters squared. Answer A may have attempted to split the shaded area into rectangles and obtained 2 times 15 plus 2 times 10 in error. Answer B may have attempted to subtract the area of the inner rectangle from the area of the outer rectangle, but used 12 times 15 minus 8 times 13 in error. Answer D has apparently attempted to split the shaded area into rectangles and used 4 times 15 plus 4 times 12. The correct response to question 2 is A, as the area equals half base times height, which equals half times 5 centimeters squared. Answer B has seemingly used base times height equals 5 times 5 centimeters squared. Answer C has apparently attempted to use half base times height, but found half times 5 times 13. Answer D has just used 5 times 13. The correct response to question 3 is B. If AD equals X, DC equals Y, the area of the rectangle equals XY, and the area of triangle BMN equals half times 1/3 X times half Y, which is equal to XY divided by 12. Answer A could have used half 1/3 X times half Y, or its equivalent, but ended up with XY divided by 24 in error. Answer C could have just used 1/3 X times half Y, or its equivalent. Answer D may have just concentrated on the height of triangle MBN, that is, BN as a fraction of the height BC of the rectangle.